Okay, and this is the last one. I'm so excited. It's the last one. All right, this is number 6. Okay, so we're told we're talking about from 0 to 6, and we have 2 circles. So, because they just want to make it as confusing as possible. So the first circle, so let's call the first circle C1. For C1, the radius equals 9 centimeters. And the radius is increasing, so that's dr over dt, at a rate of 3/2 centimeters per second. We need to find the rate, so that's our find. Find the rate at which the area is changing, so find dA over dt at that instant. And make sure we indicate units of measure, so you will lose a point if you don't have your units of measure. When they specifically tell you to put it in, you must put it in. All right, to find dA over dt, we need an area formula. So the area of a circle is pi r squared. So we're going to take the derivative of both sides. And we get that, and doing this was worth 1 point right there. Okay, now we're going to start substituting. So dA over dt is what we're looking for. We have a 2 and a pi. The r is 9, and dr over dt is 3 over 2. Okay, let's simplify. Okay, so this 2 and this 2 cancels, and we're left with 27 pi. If you did that, you got 1 point. And then you need the units of measure, which should be centimeters squared per second. And if you did that, that was worth 1 point. So that really was not so bad at all. Okay, now we're on part B. So we're told that the radius of circle 1, so circle 1 radius, is W of t, which is, well, I'm not going to copy the whole thing, but it's just W of t, and you have that whole function. And that's good for when it's between 0 and 6. When, at what time, so that's your find, so these are all related rates. At what time is the radius of the circle increasing, so that's find dr over dt, at a rate of 3. So, oh, okay, so we're not finding dr over t, we're going to find t, sorry. Let me just change that. So we're finding t when dr over dt equals 3. So they're doing a little bit backwards. Okay, so we have to end up getting a t equals. Okay, so what is dr over dt? So this is, we're going to do this a little bit differently. So they gave us w of t, and if you want the derivative of w, then isn't that just w prime? So if w of t, I'm going to write out the whole thing now, is this, then we can find w prime of t pretty easy. Okay, the derivative of 12 is 0. Here's my negative. Keep the 12. E to the anything is e to that anything times the derivative of the anything. And that would give us that. And that whole thing will simplify to this. Okay, so this thing is w of t. And for your point values, if you just did this piece here, you just bought yourself a point. Okay, so when is this thing going to be equal to 3, right? When is the derivative equal to 3? So I'm going to make some space here. And I'm going to rewrite that. So when is 6e to the negative 0.5t going to be equal to 3? And if you wrote that equation, that was just 1 more point you just earned. Okay, so we can divide both sides by 6. Okay, and how are we going to get rid of this e? we're going to add a ln to each side. Okay? And now we can use that power rule to take this exponent and bring it to the front. So we're going to get this. Okay, and we're going to keep simplifying. And ln of e is just equal to 1. Okay, we're going to go up here. So we get this. Okay, and we're trying to solve for t, so we'll divide both sides by a negative 0.5. Okay, so I mean, we need to get this, you know, as in simple form as possible. I mean, I think that they would probably take that as an answer, but they simplified it in their answer. So, I mean, if you left it like this, I really think you should get the point, but I'm going to do the simplification just to show you how to do it in case you don't know how. Now I know what your question is going to be. How do I know if they want me to simplify or not? You don't. So if you have the time and you can do it, you'll do it. All right, so really t equals ln of 1/2 divided by negative 0.5. Okay, so this is ln of 1/2 divided by a negative 0.5 is the same thing as 5/10. And that is equal to 1/2. But we're not allowed to divide by a fraction, so we're going to have to change it to multiplication, and when we do, we're going to flip it. Okay, and when we simplify this, we will get negative 2 ln of 1/2. And this is at what time? If this is in seconds. Okay, and you just needed this part. You didn't need to give the seconds, but I would just always put it as a just in case. And that was equal, the answer was equal to 1 more point. Okay, and this is part C, and now we're dealing with the second circle. So we're going to call that C2. So the second circle has a radius that we're going to call f of t, and this is going from 0 to 6 as well. So the rate of change of the radius, so that's going to be dr over dt, of the second circle is t squared minus 4t plus 4. So they gave you that. Okay, or you could think of it as f prime equals t squared minus 4t plus 4. They mean the exact same thing. So they're saying how many centimeters does the radius of the second centimeter increase from 0 to 3. So when you're hearing from 0 to 3, you should be thinking an integral, because it's going in time from t equals 0 to t equals 3. And it says based on this model, so that means we're going to use that function. And we're just going to solve that. So we're going to do the antiderivative. As it goes from 0 to 3. So let's simplify. Make some room up here. Okay, so we're going to put the 3 in there first. Okay, so that's what happens when we put the 3 in. And then you can see that when you put 0 in, you're going to get 0 everywhere, so we don't have to worry about that. Okay, 3 to the third power is 27. 27 divided by 3 is 9. Minus 3 squared is 9. 9 times 2 is 18. Plus 12. This gives us a negative 9 plus 12, which equals 3. So the question is saying, by how many centimeters does the radius increase? So you're going to say it increases 3 centimeters. Okay, and so what are the point values here? They are. If you wrote this thing, you got 1 point. If you found the antiderivative and wrote those limits, you got 1 point. And then your final answer was worth 1 point. And I'm so stoked because not only did this only take 10 minutes, but it's the last problem. Hooray!